Can you see that?
Yeah.
Okay. So one of the things that we did that I think is very important is when we went through, and you can go back and look at the video that we shared back with the spaceship configuration, where we showed how we made the H3, where we pulled the carbon out of, or disassociated it from.
This is the mystery we are asking for.
I'm sorry?
How did you pull it out?
Well, we disassociated it from the CH3. So the carbon.
I know. Well, this is the trick. We want to know how.
Okay, so the trick of how is we put it in a CO2 container with, just like we're making CO2. Let's just say that this box here, for example, is a CO2. We put a copper plate, a nano-coated copper plate, and a zinc plate over here, and we put this in salt water, and we put our CH3 in the middle of this container.
What do you mean container of the CH3? You mean?
No, this would be.
The liquid itself, you just poured it in?
No, we put it in a glass jar, and we put it in the center, and we hooked it up to the sides so that it sat in the center in the water as the CO2 was being made. And then we covered the top with a glass container so that the fields were sealed in. So as this was making CO2, we were disassociating the carbon and the hydrogen in this glass jar in the center. Is that clear?
Could you annotate that on the whiteboard?
Let's try.
When you share your screen, the top row has the whiteboard option.
Which one is the whiteboard? I see the annotate.
Just hit new share. Whiteboard's on the top row.
Next to your green.
Escape. Yeah, close the annotate right now. There you go.
And which one was the pen?
You have it. Just start drawing.
Okay. All right, so here's our CO2 box. Nano-coated copper. Zinc plate. And we put this, rather than a plastic box, we put it in a glass container. So this is in a glass container. And then we put our container of CH3. Sorry for sloppy handwriting. I'm not an expert at this. So that's hanging in this container. And the water level's like right here. Okay. And we let it sit for about 3 weeks in this container. And then we'll pull it out. And one of the things that we do in addition to it, but it's not necessary for everybody because they don't have the same tools we have. But we add, before we even start, we bubble in HHO into this container of CH3. So we call it a hydrogenated CH3. And I showed pictures before of our hydrogenator, if you will. But if you don't have one of those, don't think that you can't do it, because this I think will also get you to to where you can make the hydrogen gas. So now what you're doing is you're disassociating the carbon from the hydrogen in this container. So you still have carbon in here, and you still have H3 in here, but they're not necessarily linked together. And that's how we make it. Now, what we do when we're making our hydrogen is we'll take this same material, because we also believe that what's in here also is that this isn't necessarily all H3. It's also, because we hydrogenated it with HHO, it also contains H2, some degree of H2, and some degree of H.
How did you make the H2? How do you guess it's a H2 and how do you guess it's a H?
So we put a hydrogenator in there, and the hydrogenator bubbles in H2. In other words, it's like what do you call it? Atomic hydrogen. So what we're doing is we're bubbling in atomic hydrogen into here.
You mean molecular hydrogen? Atomic would be H, right?
I don't know what you call it. It's the same stuff that you use to power to run your cars on water.
Hydrogen gas, basically, right?
Yeah, like a hydrogen gas.
But not the HHO?
I believe it's an HHO, hydrogen gas. That's what I've been told it was.
Would it be possible that once you made the H3 and you now add your H3 to a mixture of water and mixture of, let's say, gas water of CO2, and creating again between the two plates, create a condition that you produce hydrogen, and in conjunction with a carbon you can produce deuterium, where the